Okay, in this video I'm going to be demonstrating left-hand trig, which is a way to use your body to represent math in an easier way to understand, and it's useful to help you find the points on the unit circle much faster. In left-hand trig, each finger represents a different rotation. The thumb represents a 0-degree rotation, a 360-degree rotation, and those are also known as zero rotation or 2 pi rotation. The index finger represents a 30-degree or pi over 6 rotation. The middle finger represents a 45-degree or a pi over 4 rotation. And the ring finger represents a 60-degree or a pi over 3 rotation. Finally, the pinky represents a 90-degree or a pi over 2 rotation, also known as the y-axis of quadrant. Okay. When using left-hand trig, sine represents the y-coordinate of each angle's point on the unit circle. Throughout the video, the formula square root of the number of fingers to the right over 2 will be used to find the sine of each angle. For example, the sine of the thumb is 0 because there are 0 fingers to the right and 0 over 2 equals 0. The sine of the index finger is the square root of 1 over 2 because there is 1 finger, the thumb, to the right of the index finger. The middle finger has a sine of square root of 2 over 2 because there are 2 fingers to its right. The ring finger has a sine of square root of 3 over 2 due to its having 3 fingers to the right, and the pinky has a sine of square root of 4 over 2 due to its having 1, 2, 3, 4 fingers to the right, which simplifies down to 1. Okay, in left-hand trig, cosine represents the x-coordinate of each angle in the quadrant 1 of the unit circle. In order to find each cosine, we'll use the formula cosine equals the number of fingers to the left over 2. For the thumb, it's the square root of 4 over 2 because there are 4 fingers to its left, and square root of 4 over 2 simplifies to 1. Its final coordinate is 1, 0. For the index finger, since there are 3 fingers to its left, its cosine is square root of 3 over 2. For the middle finger, since there are 2 fingers to its left, its cosine is square root of 2 over 2. For the ring finger, since there's only 1 finger to its left, it has a cosine of square root of 1 over 2. And for the pinky, since there are no fingers to its left, it is the square root of 0 over 2, which equals 0. Okay, so now we learn how to find tangent of these values. In order to find tangent, you must do sine of the angle over cosine of the angle. For example, we will do pi over 3. So from earlier we know that the sine of pi over 3 equals the square root of 3 over 2, and the cosine equals the square root of 1 over 2. So plugging it into the earlier formula, we get square root of 3 over 2 all over the square root of 1 over 2, and this equals the square root of 3 over 2 times 2 over the square root of 1, and as you can see, the 2's cancel, which leaves you with the square root of 3 over 1. And that would be the tangent of pi over 3, and this works for all of the other angles as well. And finally, to find the cosecant, secant, and cotangent of these values, which are the same ones that we use to find tangent, we will do some examples. So, in order to find cosecant, you must flip sine. So since sine is square root of 3 over 2, cosecant is 2 over square root of 3. but you cannot leave it as 2 square root of 3. So you multiply both numerator and denominator by the square root of 3 and end up with 2 square root of 3 over 3. For secant, you flip the fraction of cosine. So it ends up as 2 over the square root of 1. Can't be left like that, so you take out the square root and you leave it as 2 over 1. For cotangent, you flip the value of tangent that we found earlier, and you get 1 over the square root of 3. Again, multiply both by the square root of 3, top and bottom, and you get the square root of 3 over 3.